Well, hello my friends, and welcome to Tim's Awesome Projects. Today I want to tell you about an innovative control system that I designed, built, and tested for our custom conversion van called the Omnia. Now, if you haven't seen the reveal video for this van, please check out the link in the description below. This van includes two slide outs, making a roomy full bath and room in the back for a dining table and bench seat. Other features includes a rear-powered solid awning and outdoor kitchen prep area. This has made life in our van easier, safer, and worry-free. Introducing PCAN. What the?
You said introduce pecans.
No, not pecans. PCAN, the Perfect Campers Area Network. Before we get started, I want to mention that I will be including video markers so that you can jump forward or find sections you want to rewatch later. So let's get started and answer the question of what is PCAN? So PCAN is a network of sensors, output devices such as relays, and logic controllers. They all communicate using a variant of CAN bus, very similar to what all cars and vehicles use today. Generally, all logic controllers have access to all sensors, output devices, and other logic controllers on the network. So why did I create PCAN and use it in our van? The short answer is it simplifies the operation of all the systems in our van. To understand that, let's look at an example. First, I am using two inverters, one powered off the van's engine electrical system and one that runs off a lithium iron phosphate battery. The vehicle inverter is only powered when the van is running and is charging its 12-volt system. This inverter will power the APU's AC charger as well as the refrigerator, which runs on 120 volts, plus all the outlets. It can also run the rooftop AC blower fan so that the air conditioner is circulated from the front of the van to the back. The APU inverter can operate all those items as well as the roof air conditioner and microwave. When connected to shore power, all items can be operated, including the electrical heating element and the water heater. As you can imagine, remembering to turn inverters on and off as needed would be challenging, so the PCAN automates this process. Another nice feature is load shedding. The power management system can reduce load to match the power capabilities of the sources. You can also limit the load for shore power. The power management system will prioritize loads to keep the shore power feed from exceeding any amp draw you have set as a maximum. The microcontroller I use the most in the Omnia van project is the Arduino style Mega 2560. While one controller would be capable of controlling and monitoring everything, it made more sense to use multiple controllers so they are more conveniently located throughout the van to reduce wiring. The prototype interface circuits that connect to these controllers were hardwired on experimenter boards. Now that the design has already proven itself as being reliable, I have designed new custom interface circuit boards to take their place. The tablet used to interface with the PCAN system runs on Android, so other Android apps can be run on it as well. The tablet communicates with the PCAN system using Bluetooth. This makes the tablet portable and can be used anywhere inside the van and generally within 25 feet of the van. The PCAN app displays the date, time, and outside temperature on the top line. There are 6 buttons on the right side with corresponding status fields to the left of them. The APU, or auxiliary power unit, is another reason for needing the PCAN system. It interconnects a lithium iron phosphate battery, an AC charger, a solar charger, and an inverter. It monitors system temperatures, voltages, and currents to help protect the lithium iron phosphate battery. It can even warm the battery if it is below freezing before it will allow it to charge. It warms the battery using the charging sources so it won't consume battery power. The top line is for the APU. It displays the APU's battery percentage and charge or discharge rate. It will indicate the status of the APU inverter. Under that, in the same box, it displays any warning or alarm notices along with an estimated runtime abbreviated by ERT. Since the display is indicating a warning message in this case, the battery is not charging with an AC input, the status display will be yellow. If there is an alarm condition, the status field will be red. If all is good, it will be green. If ERT displays NDC, that means the battery is not being discharged. Otherwise, the ERT, or estimated runtime, will indicate how many days, hours, and minutes of battery charge are remaining with the current load status. Pressing the APU button or the APU status box will bring up an APU details panel. The top box in this panel will display battery charge in percentage and includes a bar graph to visually indicate how much charge is left. As the battery level drops, it will turn yellow and then red as it nears 0%. Also in this box, it will display battery charge or discharge rate along with the current battery voltage on the right-hand side. The next box down displays the AC charger status. The AC charger is powered from shore power or the vehicle inverter when the engine is running. The bottom line of the box indicates the charger output in amps and watts. The right side displays input voltage to the charger as well as the output voltage from the charger. The third box down displays the solar charger status. The bottom line in the box displays the solar charger output in amps and in watts. The right side of the box displays the voltage out from the solar panels as well as the charger output in volts. The fourth box down displays calculated system load. The bottom line displays load in amps and power in watts. The right side of the box displays the APU inverter output voltage as well as the load on the inverter in amps. The fifth box down displays the inverter status. There are three modes the inverter can operate in: auto, forced on, and forced off. In the auto mode, the inverter will turn on if the shore power is disconnected and if the vehicle inverter is not on. To change the mode of the inverter, press the inverter mode button and select the mode wanted. The next to the last box down displays various temperatures in the APU. The last box down indicates if there are any alarms or notices. Pressing the Alarm Details button will display any active alarms or notices in the APU unit. In this case, the AC input voltage too low notice is displayed since we don't have any AC charging voltage coming in. You'll also notice that it says the APU controller reset. This is just a general message that the APU controller was powered down since the alarms were last acknowledged. So generally, when we are traveling and we find that we need air conditioning to sleep at night, we will look for a campground, preferably a state park or similar with reasonable fees. If we can't find one, we will find a rest area and leave the van idling with the air conditioning running. This is another reason for the PCAN system. We will take the tablet and place it in the rear of the van, and it will alert us if any abnormal conditions occur with the engine. Of course, we also have a high-quality carbon monoxide and smoke detector to help guard us while we sleep.
The second status line on the tablet is for monitoring of the engine. You will notice that the display currently reads engine off and is grayed out. This is because the van is not running. So now if I start the van, you will see the engine status start to show data, but it is red, indicating an alarm condition. In this case, it is simply because the data needs to be fully updated. Once that has occurred, usually within just a few seconds, it will go green, indicating that all monitored engine sensors are okay. The engine status box will show engine temperature, oil pressure, and battery voltage. It also shows the status of the vehicle inverter. Once the voltage is okay, the vehicle inverter will be turned on. One item that will only show up when in an alarm condition is a low coolant condition. Since this model of van didn't include a coolant level sensor, I added an external fluid proximity sensor to the coolant catch tank. Should the van develop a coolant leak, I will be notified before it starts to affect engine cooling capacity. The third status box down is for the HVAC. It shows the temperature for inside the van, the HVAC current mode, and fan status. Clicking on the HVAC button or its status field will open the HVAC details panel. The top line here also shows the HVAC current mode and fan status. Below that is the van temperature as well as relative humidity. The two red buttons are used to set the minimum desired temperature. The two blue buttons are used to set the maximum desired temperature. The bottom left button allows you to turn the HVAC system on or off. When it is highlighted in green, it is currently on. The button to the right of it sets the fan mode. When it displays auto, the fan will only run when needed. If set to manual, it will run continuously. The lower right side of the HVAC details panel provides 3 fan speed settings: low, medium, and high. The active fan speed will be outlined with yellow. The top right of the HVAC details panels has an icon for HVAC settings. This brings up an HVAC settings panel. The fan vehicle inverter enable checkbox, when checked, will allow the rooftop AC fan to run when the vehicle inverter is on. The APU inverter cooling enable box, when checked, allows the rooftop AC to function when the APU inverter is either on or is in the auto mode. The APU minimum battery percentage setting is the minimum APU battery level at which the rooftop AC unit is allowed to run. The APU on demand enable box, when checked, will turn on the APU inverter even if it is in the forced off mode. The minimum battery level is still enforced though, so it will not run below that point. The auxiliary heater enable box, when checked, allows the rear van heating system to run using the auxiliary glycol heater, which runs off the main gasoline tank. The auxiliary engine heater enable box, when checked, allows the rear van heating system to run using heated coolant directly from running the engine. The fourth status box is for controlling interior lighting. This is a future project I will be working on soon. It reads no connections since there are no light controller modules detected.
So the PCAN system allows us to monitor our freshwater system as well as our black water holding tanks. It also gives us a detailed look at our entire electrical system in the van.
The utility status box displays the temperature of the water in the water heater, followed by its mode of heating. Currently, no modes are active, so it reads inactive. The last part of the utility status indicates the source of the power for 120 volt appliances and outlets. Since we are running off the APU inverter, it displays that with its voltage output. Selecting the utility button or status field will open a utility window. This window has tabs at the top to select subsections. The default section to display is for the holding tanks. On the left, we have a graphic representation of the freshwater holding tank, along with its percentage full. The next section over, there are 2 buttons for the water pump to enable it or disable it. The fill valve on box, when checked, will fill the freshwater tank from the city water connection. The pressure readout is for the water pressure. The last graph is for the black water tank and displays from 0, being empty, to 3, being full. The next tab at the top will display the power system block diagram view. This view is arranged into 4 sections. The first section represents the APU. The yellow lines represent DC voltage between the different power modules. On the left side, it has modules representing the battery, solar charger, and AC charger. The modules on the right represent the APU inverter and the 12-volt DC converter, which converts the internal 24 volts to 12 volts DC. The next section represents the vehicle 12-volt system and the 2000 watt vehicle inverter. The bottom left section represents the shore power utility connection. The section on the right represents the power monitor system and its relays. The black lines indicate 120 volt AC connections between the various modules. The top right module indicates the SA relay. The SA relay switches between shore power and the APU inverter. Currently it is switched to the APU and feeds the galley outlets, including microwave and the outdoor outlets. The VSA relay switches between the vehicle inverter and the output of the SA relay. Therefore, it can feed power from either of our two inverters or from shore power. The devices and outlets powered through the VSA relay are listed to its right. The SV relay switches between shore power and the vehicle inverter. It is used exclusively for the APU AC charger to charge the APU battery. Since neither the shore power inlet or the vehicle inverter have power at this time, the AC charger is grayed out. The last item listed on the right is the water heater. There is no visual representation for its relay, which is only fed directly from shore power. It is grayed out as well since there is no power connected to the shore power. Pressing the heating tab will open a page displaying hot water heater settings, the auxiliary glycol heater settings, and a couple of other items. In the water heater section, it shows the current water tank temperature on the first line. Below that, there is a checkbox to enable water heating when connected to shore power. The next line down allows the water to be heated using the auxiliary glycol heater. The auxiliary heating set point determines how hot it will heat the water to. The engine heating set point determines the temperature the engine will heat the hot water to. If we are planning on boondocking, I will set this as high as 180 degrees. That will usually give us enough hot water to last at least 2 days without any additional heating. Although it will heat as high as 180 degrees, a mixing valve will regulate the hot water temperature going to the shower and faucets. I have that set to 110 degrees. One other feature found listed below the hot water heater section is the hot water recirculate. This sends hot water from the hot water tank through all the hot water lines and back to the fresh water tank. It will shut off after about 30 seconds. This is useful to conserve water instead of running a faucet waiting for the water to get hot. The auxiliary glycol heater lists the status and parameters of the auxiliary glycol heater when it is operating.
The other big advantage of the PCAN system is safety. There are sensors located on the leveling jacks, cargo doors, slide outs, and more. If any of these are not in a travel safe position, the PCAN will give an alarm when the van is started.
So let's take a look at the travel section on the tablet. The white box near the middle of the screen represents a top view of the van, with the top of the box being the front end of the van. The green boxes indicates various sensors, including slide out close sensors, equalizer jack up sensors, and compartment door close sensors. When any of the sensors are detected to be in a safe for travel position, the corresponding box will be green. Otherwise, it will be displayed in red. The dark blue buttons control the rack-mounted floodlights. They can be switched on and off independently or as an entire group. The cameras button brings up a camera panel that allows you to change when the cameras are powered on. Auto mode only powers up the cameras when the van is running. The force on mode will power the cameras all the time, so they function and record even when the van is off. There are two buttons for controlling the airlift suspension. The left and right are controlled independently. To change the set point, click on the left or right button and enter the desired setting. The pressure will then automatically adjust to the desired level. On the right side, there are buttons so we can enable or disable the onboard air compressor. When on, the air compressor will cycle on and off to maintain pressure. When off, it will be disabled.
Oh, I see you're almost done watching the video. Give me 1 second. So there are more features to PCAN than I've mentioned so far. Plus I'll be adding more as time permits because PCAN is easily expandable. But the best feature of PCAN is once you have it set up, you can forget about it because it'll take care of everything for you. So, thought of the day. May pecans be plentiful. All right, thanks for watching. This looks good.